gas properties, we will use the FAT interactive simulation. So we will choose the ideal. Okay, as you can see here, the temperature is in Kelvin, so we change it to Celsius. And okay, this a plus here at particles. There are two types, the heavy and light. The heavy is in blue, the light one is in red. We can choose either one. So for me, I will choose the light particles. Okay, and that at the 50. Now we just need to observe the movement of the particles. As you can see here, in room temperature, the particles are moving and bumping at the wall. Okay, how about we increase the temperature? Okay, there is a bucket here. Okay, this means that we are increasing it. Okay, so it become faster and faster, and it means that the kinetic energy increase. What if we make it colder till as we can see, it becomes slower and slower, and the frozen is this is its state when it's frozen. It barely move, and when it bump to the walls, it become much slower. And this is when it almost reach the absolute zero temperature, which we are going to learn next. Okay, for now, what if we increase the volume and just let's rise up the temperature. How constant here? Volume is not constant. Oops, pressure cannot have constant. Volume would be too large because PV, if pressure is increased, this is Boyle's law. If pressure increase, the volume increase too. So this is already the limit. So if we increase the pressure, the volume need to increase too. So in this case, we cannot increase the pressure, otherwise it would explode. What about how do we want to know the volume of the container? We fill it with lots of molecules. So if it fill up all, then the volume of the gas is equal to volume of the container. It is one of the gas properties. No, 1000 is maximum. So, okay. Then, next, should we look at the gas properties?
Charles' law. Charles' law states that for a fixed mass of gas, the volume of gas is directly proportional to its absolute temperature and its pressure is kept constant. The formula is V1 over T1 equal to V2 over T2. Let's start the question. A container holds 50 ml of nitrogen at 25 degrees Celsius and pressure of 736 mmHg. What will it be its volume if the temperature increased by 35 degrees Celsius? In this question, we are not using pressure because it already said about volume twice in 25 and 35. So the volume one will be 50 and temperature 1 is 25, but it is in degrees Celsius. We need to convert it to Kelvin, so we add 273.15, so equal to 298.15. in Kelvin. Then volume 2 is unknown. Temperature 2 is, it said that the temperature increased, so we just need to add T1 plus 35, so equal to 333.15. The formula is V1 over T1 equal to V2 T2. So just insert the value 50 for T1 to 98.15. V2 is unknown, or we should use V2. And the T1 and the T2 is 333.15. Then cross multiply, we get 50 times of 333.15. One 57.5. So V2 equal to 55.9 Don't forget the unit ml. So this is the answer.
After Charles' law, we have pressure law. Pressure law states that for a fixed mass of gas, the temperature of the gas is directly proportional to its absolute temperature and its volume is kept constant. And the equation is P1 over T1 equal to P2 over T2.
Let's move to the question. A gas has pressure of gas has a pressure of 669 milligram Hg at 40 degrees Celsius. What is the temperature at a pressure of 760 mmHg? So we need to find the temperature. So pressure law, 669 milligram Hg is the pressure 1. Pressure 1 equal to 699. Temperature 1 equal to 40 plus 273.15 equal to 313.15. Okay. So pressure 2 is 760, but temperature 2 is unknown. So pressure law is P1 over T1 equal to P2 T2. So just fill in the formula. 699 over 313 313.15 equal pressure 2 is 760 T2. So cross multiply, we get 699 T2 699 T2 equal to 237,994. So T2 equal to 344.9 K Kelvin. So this is the answer.
After pressure law, we have Boyle's law. Boyle's law states that for a fixed mass of gas, the pressure of the gas is inversely proportional to its volume when the temperature is kept constant. Its equation is P1 V1 equal to P2 V2, where P is gas pressure and V equal to volume. Next, we start with the question. Feel free to pause the video to do the question first and then resume to see the answer. A gas occupies 12.3 at a pressure of 40 mmHg. What is the volume when the pressure is increased to 60 mmHg? Here we got two parameters, which is volume and pressure. the pressure and the volume, the first volume is equal to 12.3. The unit is in liter, and we need to find the volume. So V1 equal to 12.3, B1 equal to 40, and volume 2 is, we need to find the volume 2. So volume 2 is unknown, and the pressure 2 is equal to 60. So as we know, the P1, V1 equal to P2, V2, V2 so just put in the value. So V1 equal to 12, P1 equal to 40 times 12.3, so P2 is 60, the V2 is unknown, and after multiply by 40 times 12.3 equal to 492, equal to 60, V2, that's it. Now we need to divide 492 by 60, so we got 8.2 liter. Don't forget the unit.
Then let's move on to absolute zero temperature. If you remove heat from a substance, its temperature drops. For example, if we have a substance here, if we remove heat, the temperature will decrease. But if we continuously remove heat, keep removing heat, you will reach a temperature at which all the particle motion in here almost stops and kinda not moving, which is equal to negative 273 degrees Celsius. This temperature is called absolute zero temperature. It is the kinetic energy is so small that it almost equal to zero. And if we do absolute zero temperature experiment, and we will get this graph, which, and if we extrapolate, we'll get here negative 273, and it's the lowest possible temperature, which is negative 273, negative 273 degrees Celsius. To convert degree Celsius to Kelvin, just add 273. So you get the unit temperature in Kelvin. And to convert Kelvin to degree Celsius, we do the opposite, which is minus K minus 273. Then we will get the temperature in degree Celsius.
Now let's discuss about the Avogadro law. For a confined gas, the volume and the number of moles are directly proportional. So, V is directly proportional to number of moles, and if the pressure and the temperature both remain constant. So if we were to change it to become an equation, it will be like V equal to K, and K mean constant. So V1 over N1 equal to V2 over N2. So this is how we got the equation for the Avogadro law. Then let's move on to ideal gas law. Okay, we have discussed Boyle's law, pressure law, Charles' law, Avogadro's law. What if we combine all of these? If we got PV equal to nRT. P is pressure, V is volume, N is number of moles, R is the constant, and T is temperature. We have the value of R. R can be is 0.08 to 06 atm, mole -1, Kelvin -1, or if you use kPa, we need to use 8.314 kPa, L mole -1, and K -1. After ideal gas law, we have combined gas law. It combines three different gas law, which is Boyle's law, Charles' law, and pressure law. It's the ratio of pressure and volume and the absolute temperature of a gas, which is equal to a constant. So the formula is P1 V1 equal to T1 over T1 equal to P2 V2 over T2. This is the formula which can use three terms simultaneously. Do take note. So let's do some exercise on combined gas law. Before that, do pause the video to do and then resume if you want to check the answer. Question 1. When filled with air, a typical scuba tank with a volume of 13.2 liter has a pressure of 153 atm. If the water temperature is 27 degrees Celsius, how many liters of air will such a tank provide to a diver's lung at a depth of approximately 70 feet in the ocean, where the pressure is 3.13 atm. So first we need to identify the parameter. So P1 equal to 153, here 153, and V1 equal to 13.2, equal is here, and temperature of 27. So if 27 plus 273 is 300. So we got temperature 1 equal to 300.15. And P2 equal to 3.13 atm. 3.13. And V2 is, we need to know right here how many liters of air will such a tank provide. So we know the volume is unknown, and temperature 2 is, and temperature 2 will be the temperature of the lung, which is the human temperature is 37. So plus 273.15 equal to 310.15 K. So by using the combined gas law equation, we get, I just fill in 153 times 13.2 divided by 300.15 equal to 3.13. V2 is unknown, so equal to 8 divided by 310.15. So cross multiply, we get 153 times 13.2 times 310.15. So we get 6 to 6. I will continue here. 6 to 6, 378.94 equal to 300.15 times 3.13. So we get 939 or 0.46 V2. So divide 6 to 6, 378.94 divided by 939. We get V2 is 666.7 liter. Don't forget the unit.